Welcome back. So we're gonna take a look at the geometric series now. We talked about the sequences yesterday, where sequence is just a list. Series in math, whoops, I do this every time when I start a video. Series in math, plain and simple, means sum. So we're gonna be adding things together. So I'm gonna change up the notation a little bit. As you can see, there's two types. We got infinite and we got finite. Infinite means it goes on forever. You got your infinity. Finite means it stops. So we're going to start by looking at finite, and then we're going to look at infinite later. I got a couple typos, but we'll be okay. So my sum of a geometric series. So S sub n is going to mean sum of the series equals G sub 1. Remember, G sub 1 is your first term. 1 minus r to the n over 1 minus r. And r can never equal 1 because you're going to have 0 in the bottom. So we can't multiply by 1 because then it's kind of pointless. We're not doing anything. So remember here, this is simply just meaning your sum. That is your first term. Wow, that's bad. R is your common ratio. And n is your number of terms. So just a little bit kind of looking at it, and we're good to go. All right. So example number 1, we're going to find the sum of the first 7 terms. So that tells me right here, if I'm just kind of listing stuff, n is equal to 1. So S sub n is equal to G sub 1 times 1 minus r to the n over 1 minus r. So I'm finding the sum. So I need to find n, I need to find G sub 1, and I need to find r in order for this formula to work. G sub 1 is my first term, so that one's easy to get. N is right here, so n is 7. Don't know why I wrote 1, but n is 7. It's the number of terms. And then what am I doing each time? So to get from 3 to 6, I'm multiplying it by -2. To get from 6 to 12, -2, so my r is -2. Remember, you could always do -6 over 3, your second term divided by first term, and you get your r as well. So S sub n equals 3 times 1 minus -2 to the 7th power over 1 minus -2. Let's simplify what we can. So 1 minus -2 to the 7th power is 129. 1 minus -2 is a plus, so that becomes a 3. Those cancel, so S sub 7 is equal to 129. You can leave it as S sub n. I like to put S sub 7 because that reminds me that I found the sum of the first 7 terms, and that gives you 129. If you did it by hand, so this is 1, 2, 3, 4. So I got -24. I'm going to times it by -2. That's 5, 6, 7. And if I took all these numbers and added them together, you get 129. That's the definition part. That's what's going on. And that's kind of what we are doing. All right. If you want to pause it and try this next one, you can. So I want to find the sum of the first 6 for this formula here, or this sequence series, whatever. So S sub n is equal to G sub 1 times 1 minus r to the n over 1 minus r. So remember, I need to find the first term, I need to find my n, and I need to find my r for this to work. So my first term is 2, my n is 6, and my r is going to be 1 over 2. Nice and easy. So G sub 1 over, or G sub 2 over G sub 1, and that's what got my 1 over 2. I'll clean this up. So S sub n is equal to 2 times 1 minus 1/2 to the 6th over 1 minus 1/2. So if you keep it organized, 1 minus parentheses 1/2 to the 6th power. Hit math, enter. Get your fraction, so 63 over 64. I don't like decimals. 1 minus 1/2 is 1/2. So if I do 63 over 64 and divide that by 1/2, math, enter, you get 2 times 63 over 32. multiply it by 2, so you get 63 over 16 is S sub 6. And you got your answer. Always hit that trick, math and enter, convert it back to a fraction because it's easier to use. All right. Summation notation is something new. So this giant sigma means sum. So what I'm going to do here is I'm going to kind of figure out the different parts, kind of looking through this. So sigma means sum, so that means sum. This is your first n. This is your last n. And then this is your explicit rule. That whole thing right here. It's always equal to the explicit rule. So since I see a fraction raised to a power, that tells me it's geometric. So I know here S sub n is equal to g sub 1 times 1 minus r to the n over 1 minus r. So let's look at a few things to kind of help you out. This inside your fraction will always be your r. So if I'm listing these, g sub 1, r, and n is what I need. So my r is 1/3. To find your n, in summation is always top minus bottom plus 1. So 5 minus 1 plus 1. So my n here is going to be 5. Okay? Now to get your g sub 1, g sub 1 is your first term. So I'm going to plug in the bottom number. Whoops, backwards parentheses. So g sub 1 is equal to 1/3. My k is 1, so 1 minus 1. So 1/3 to the 0 power. Anything to the 0 power is 1. So I have everything I need to know. So once again, going back through that, so this is a lot of information to throw at you. What is in the parentheses is always my r. If you want to plug in 1 and then plug in 2, because it started here at 1, you can, and then divide them and get r. That's a longer way to do it, but it always works out. And then to get your n, it's always your top number minus your bottom number plus 1. So now I can solve this. So g sub 1, my r, where did I write it? 1 times 1 minus 1/3 raised to the 5th power over 1 minus 1/3. So S sub 5 is equal to, excuse me, 1 minus, parentheses, 1/3 raised to the 5th power. Math, enter, enter. You get 242 over 243 divided by 2/3. So I'm going to divide that by 2/3. Math, enter, enter. So your S sub 5 here is 121 over 81. And that is your answer. So summation notation's a lot. Watch this a couple times to make sure you understand what's going on, what I'm talking about, because I'm throwing a lot of vocab in here to kind of make things a little bit more challenging for you, but it's okay. All right. This is a 2. I don't know what happened here when I copy it over, but it always does this. So let's look at this a little bit different. Okay. So remember, sigma means sum. I see I have something raised to the power, so this is geometric. So S sub n is equal to g sub 1 times 1 minus r to the n over 1 minus r. So remember, I need to find my g sub 1, I need to find my r, and I need to find my n. All right. So remember, your r here is what's in the parentheses, what's getting raised to the power, so your r is 2. My n is always top minus bottom plus 1. So my n is going to be 6. G sub 1, I'm going to plug in my bottom number. So I got negative 3 times 2 to the 0 power. 2 to the 0 power is 1, so my g sub 1 is equal to negative 3. So my g sub 1 is negative 3, my r is 2, and my n is 6. We talked about this, and now I can zoom in over here. I have enough information now to solve and find it. So sum of my first 6 terms, because my n is 6, g sub 1 is negative 3. 1 minus 2 to the 6 over 1 minus 2. So I get negative 3. 1 minus 2 to the 6th power is negative 63. 1 minus 2 is negative 1. So I have negative 3 times 63 now. So my sum of my first 6 here is negative 189. And you're good to go. And you can keep plugging these in if you want to. You can do it the old-fashioned way. I can plug in 1, plug in 2 until you plug in 6 and get your answer. But that's how we can work through this. So I would once again pause this, work through it a couple of times, make sure you know how to get your G sub 1, your R, and your N, and then use your formula to get your answers. This is the finite side of your geometric series. Now, we're going to go look at our infinite side now. So the sum of infinite, we got a little bit more work to do here. So I'm going to come over here and write some things first for you. So when the absolute value of R is less than 1, and I'll clear this up, and the partial sum approaches a fixed number, the series is said to converge. And then on the opposite side of things, when the absolute value of R is greater than 1 and the partial sum does not approach a fixed number, these series is said to diverge. We'll talk about what this means in a second. So when the absolute value of R is less than 1 and the partial sum approaches a fixed number, the series is said to converge. When the absolute value of R is greater than or equal to 1, forgot my equal sign, and the partial sum does not approach a fixed number, then the series is said to diverge. So when we're talking about infinite series, we have to first see if it's going to converge or diverge. So what happens here is if it converges, we have a sum. And remember, this is when the absolute value of R is less than 1. I did it in red. If it diverges, my answer is no sum, and you're done. And that's when the absolute value of R is greater than or equal to 1. Now, if it converges, we do have a sum. So my sum formula here is S is equal to G sub 1 over 1 minus R. If it diverges, my answer is no sum. So that's kind of what we're going to use here. If it's finite, which means it ends, I give you a stopping spot, like this has a number up top. It's finite, so we have to use this big, long formula. Infinite, if you look down here, we have the infinity sign, or it doesn't give you a stopping spot. So we're going to have to figure out, does it converge or does it diverge? If it converges, we have a formula to use. If it diverges, your answer will be no sum. So let's take a look at a couple of these. So here, I see that there is no stopping spot. I got the ellipses at the end, so it's going to go on forever and ever and ever. So to find my R, it's G2 over G1. So negative 5 over 25. I just did that. So if I reduce this, I get negative 1/5. All right, so the absolute value of negative 1/5 is 1/5. That is less, the absolute value is less than 1. So since it's less than 1, that tells me it converges. Okay, so if it converges, I have a formula. So S is equal to G sub 1 over 1 minus R. So G sub 1 was my first term, so 25 over 1 minus a negative 1/5. So my sum here is 25 over 6/5. because remember, if I take 5 over 5, which gives 1 plus 1/5, you get 6/5. So keep, change, flip, and you get 125 over 6. So once you know if it converges or diverges, it tells you what you need to know. Since it converges, you get a solution. If it diverges, you don't. Most of the time you will converge, that way you have something to do. All right, let's take a look at this. I got an ellipsis at the end, so let's find our R. So R is 4 over 5, which is roughly 0.8, so it converges. So S is equal to G sub 1 over 1 minus R. So S is equal to 5 over 1 minus 0.8. So 5 over 0.2, which is 25 if you plug it in your calculator. Nice and quick. 0.8 is an exact decimal, so I don't mind using that. In the previous ones, they were crazy decimals, so I do mind using that. All right, let's look at one with a sigma. So I see now I have an infinite sign up top. So I need to take a look at this. With this one, it's really hard for me to tell because I got a bunch of stuff in the parentheses. So here's how I'm going to find my R. So I need to find my R. The way I'm going to do this is kind of the long way. I'm going to find my first term, and then I'm going to find my second term. So if I find my first term, it starts at 1. I'm going to say 2 over 3 to the 1 minus 1 power. Just 2 over 3 to the 0. Anything to the 0 power is 1, so I get 2. That's my first term. Now I want to find my second term, so I'm going to plug in 2 for my k. So this is my first term. This is my second term. So remember, R is G2 over G1. So I have 2/3 divided by 2. So 2/3, divide that by 2. You get your R is 1/3 here. So 1/3, oops, go away. 1/3, the absolute value of 1/3 is less than 1, so it converges. That's a C. So my formula here, I'm going to use S is equal to G sub 1 over 1 minus R. So we found our G sub 1 was 2. 1 minus 1/3. So I got 2 over 2/3. So my sum here is just 3. And we are good to go. So I hope this helps. I know it's a longer video. I know it's a lot of new information. But please, please, please practice this. It's not going to click until you practice this. You got a couple sheets, one on finite, one on infinite. The answers are at the bottom. If you have questions, please talk to me. But other than that, hope this helps. Pause it, make sure you got the definitions down, and you are good to go. So I hope you have a wonderful rest of your day, and I will talk to you soon.